Hey everyone, this is Rishabh and welcome back to Code Shastra. In the last video, we learned the core theory of CNNs, in which we have discussed about filters, feature maps, convolutions, pooling activations, and architecture flow. In today's video, it is the most important one because now we are going to open Google Colab, write some real codes, build a complete CNN project, train the model, evaluate it, and even visualize how the CNN looks at the images. This is the video which is going to be a deep, very deep. So sit back, focus, and follow along the step by step. Alright then, let's start. Open your browser, go to Google Colab, click new notebook. First step is going to import all the essential libraries for our project. So we are going to import TensorFlow, Matplotlib, and NumPy as well. So TensorFlow plus Keras is the simplest and most powerful way to build the CNNs. After that, image dataset generator helps to load and augment the image. What augmentation is, we have already discussed in the last video. So yes, this is going to help in this way. After that, Matplotlib is for visualization. Okay, after importing and installing all the essential libraries, we need to load a data set. Okay, so this is how we are going to load a data set using the TensorFlow and Keras. So when we load the data set, the image are of 32 by 32 RGB images. uh, okay, so for beginners the best data set is CIFAR10. It has 60,000 colored images belonging to the 10 classes like elephant, dog, cats, etc and etc. So yes, we can load dataset by this line. After that, let me show you an example of the image from the dataset. So this is the one example. As I already told you, images are learned by the CNN in a grid form. We have already discussed it. So this is the example for that one. Next step is going to start the data pre-processing process. So very first we're going to normalize our data. Okay, so this is for normalizing our data. We always normalize images so that pixel values lie between 0 and 1. Okay, that is why we need to normalize the data. This helps the CNN to learn faster and more accurately. After that, it comes the important one and the real magic of our model. That is the point where we really apply CNN. So we build a 3 block of CNN, which is having one conv, one activation, which is ReLU, and a pooling in which we are using max pooling 2D. As we are using conv 2D, that is why pooling function is max pooling 2D. Okay, so conv 2D means we apply 32 or whatever 64 of 3 by 3 size, right? ReLU is the activation function. So we have discussed already, but let me tell you again that ReLU removes negative values and speed up the training process of your convolutional layer. Okay, after that, pooling function, which is max pooling. So max pooling reduces the spatial sizes and keeps the dominant features. Okay, it keeps the dominant features which are essential for training our model. After these 3 blocks, it allows the network to learn the hierarchical structure in which we got edges, texture, and shapes of the images. So this goes like that. After that, we got some connected layers. Okay, by this we got some connected layers. So this flatten breaks the 3D feature map into a long vector. Okay, we are having the 3D feature map by these applying these layers before. So this is necessary to make it into a long vector. That is why we use the flatten along with the layers. It makes it into 3D images are converted into the vector form. And after that, the dense layer, that act like a traditional neural network. Okay, we apply dense layer on the layers, so it works like a traditional neural network. After this, our softmax function, ReLU I already told you, then it comes after, then after comes the softmax function. So the main work of softmax function is to convert the numbers into the probabilities. Okay, as we are going to predict, so we need probabilities. Then after we need to compile. Okay, sorry, we need to summarize first. Yes, then after we need to summarize. So you here you can check all the total layers and all the trainable and non-trainable params for each layer that we have applied. We applied first con 2D of 32 units, then after second layer, then third layer, and whatever the parameters are given we have provided. Whatever the training process was there, you can check it from this code. Okay, so this was a short summary of our params that we have given for training of our model. Then after it comes the compilation of the model. Okay, so here we are compiling using the Adam optimizer. It adjusts the weight efficiently. After that it comes the loss function of our model. So loss function compares the predicted versus the actual labels. Okay, after that we measure the accuracy, that it shows us that how well our CNN model is working. Okay, so that was it. After that it comes the fun part, that we train our CNN model and we see the history. So how we are going to train it? We are going to train it on 10 epochs. So I have already trained that model on 10 epochs, and it takes some time to train. So yes, epochs mean one full pass of dataset. Each epoch, the CNN updates the filter to improve the prediction. So during the training, you will see accuracy is increasing and loss is decreasing. Okay, accuracy first started from 0.34 and goes till to 0.78, and loss is started from 1.77 and goes for 0.61. So accuracy is increasing and loss is decreasing. Okay, so that was it. After that, uh, we have plotted the training accuracy graph. So this graph help us to detect the overfitting and underfitting of the model, as it shows two lines of accuracy. One is for training and validation, so we can predict that what was the our model's performance, whether it is in overfitting condition or it was in a underfitting condition. So after that we have evaluated our performance on unseen images. Okay, yes, we have evaluated it, and it gives us accuracy of 0.7067%. Okay, so basically it will be 71% of accuracy it is giving us. Okay, thereafter we have to make the prediction. So this is the image for which we are predicting our model. So this is the single image of index 40 in the dataset. So this is the last part which I have already discussed in the previous video of CNN theory. So this is the most simplest code for Grad-CAM. So Grad-CAM shows which part of the image the CNN basically focuses on. Okay, so this is not the full code of Grad-CAM. This helps us to understand how CNN see the image internally. By next video, I'm going to do the full code of the Grad-CAM, because this needs to be covered in detail. So there will be another dedicated, a separated video for it. So yes, this was the complete our part 2 of our CNN series. So we built a full trained CNN model, tested it, and even visualized how the images work. Okay, so if you want part 3, we are going to do object detection using CNN. So just drop a comment below, and please do like, share, and subscribe Code Shastra.